everybody, we're getting ready to do lesson 8.2 for Algebra 2 math. This will be part 1. If you need part 2, part 3, email me here and I'll get that out to you. If you need worksheets, if you need tests, if you need quizzes for this course, I have them all in PowerPoints or video. So email me for that. 8.2, graph and write equations of parabolas. Here is our standard, and we're in quadratic relations and conic sections now. We have a classwork sheet of 30 points, and we have a notebook guide that's got 10 points in that as well. Teachers, here is the bell work for your students. Give your students 5 minutes to do this bell work. Okay, welcome back, and then here's the solution for our first spell work problem up here. And then this will be our solution for our second spell work problem here. Okay, graphs. And graph and write equations of parabolas. You graph and write equations of parabolas that open up or down. You will graph and write equations of parabolas that open left or right. Sound projection. Here is a graph of y equals ax squared as a parabola that opens up or down like this. Here's a parabola here. It opens up. So you know that the A segment of that quadratic is positive. With a 0, 0 vertex and axis of symmetry would be x equals 0. Axis of symmetry is here. Vertex lies halfway between the focus and the directrix. So this would be a vertex here. Each point is equidistant from a point called the focus. Now the focus and a line called the directrix. So the vertex lies halfway between the focus and the directrix. So this would be the focus here. This is the focus here. And then the directrix is called the directrix. The focus lies on the axis of symmetry. This is the focus here. And the directrix is right here. This is the directrix here. The directrix is perpendicular to the axis of symmetry. So you have a 90-degree angle here between the directrix and the axis of symmetry here. Vertex, the directrix, and then the focus lies on the axis of symmetry, which is equidistant from a point called the focus. So on any parabola, each point is equidistant from the distance to the focus here. So the distance that goes from here to the directrix is the same length as from here to the focus. Same thing here. Same distance here from to the focus to the directrix, which is here. Okay, students, define focus and now define directrix. Okay, so the equation of a parabola that opens up or down and has a vertex at 0, 0 can also be written in the form of x squared equals 4py. Parabolas can open left or right as well, in which case the equation has the form y squared equals 4px when the vertex is 0, 0. So y squared equals 4px or x squared equals 4py. So we have two different kinds of parabolas here. Note below that for any parabola, the focus and the directrix each lie an absolute value of p units from the vertex. So we have an equidistant kind of relationship between the focus here and the directrix. Okay, here is a diagram again. X squared equals 4py. So x squared equals 4py. We have our directrix here. Here's our vertex and our focus. So we have equal distance here and then an equal distance here to our directrix here. Directrix would be y equals negative p of our equation down here. And then for here, x squared equals 4py. P is less than 0. Here, p was greater than 0. So p now is less than 0. So we have a negative element for our quadratic function here. So our parabola is going to point down now instead of up. Here's our focus. Here's our directrix here. Equal distance here to here is equal distance. Then now we have y squared equals 4px. P is greater than 0. So now our parabola is going to go like this, and the y squared equals 4px formula there, or this equation here. Here's our focus, and then here's our directrix here. Equal distance here to equal distance there. And our vertex would be here. And then now we have our y squared equals 4px, where p is less than 0. It's going to point now to the negative, towards the negative side of the number line. Then here's our focus, and then here's our directrix here. So these are the relationships here, and this is in your class worksheet. This is really nice. Okay, key concepts, standard equation of parabola with vertex at the origin. Standard form of equation parabola at 0, 0 is as follows. So we have x squared equals 4py, focus is 0p, and then the directrix is y equals negative p, and then the axis of symmetry is x equals 0, and then again here, y squared equals 4px, p0 is our focus, and then our x is negative p, will be the negative p here, and then the horizontal axis of symmetry is y equals 0. So it would be the x-axis, this is the y-axis here. Okay, let's get an example of this. Graph an equation of a parabola. We have this here. Identify the focus, directrix, and axis of symmetry. We write the equation in standard form. So x equals negative 1 over 8 y squared. Equation. So multiply each side by negative 8. We're going to isolate our y. So y squared equals 4px, where p is negative 2. P would be negative 2 here, because that would be, make this negative 8, so p will be negative 2. The focus is at p0, or negative 2, 0. The directrix is x equals negative p, so, or x equals 2, so x equals 2 would be our directrix. And because the y is squared, the axis of symmetry will be the x-axis, so we got something like this. So the graph of that, draw the parabola by making a table of values. Here's our table of values here. We have plus or minus values here because we have a squared. Y is squared. So this would be what the parabola would look like here. X equals 2 would be our directrix here. And then because P is less than 0, parabola opens to the left. So we have an open to the left situation here. So use only negative x values for this. So negative x values for this. When x equals negative, 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 negative. And then here plus or minus 2.83. We have this, and then plus or minus. So we have plus and then minus y values here for this parabola. Okay, let's do the one ourselves. Y squared equals negative 6x. Students, this is yours. X squared equals 2y. Y squared equals negative 6x. This would be the graph for it right here. X equals 3 over 2, and then negative 3 over 2 equals 0 will be our focus here. Focus is here, directrix is here. Axis of symmetry would be the x-axis. The focus would be P0. P0 would be our focus. Negative 6x equals 4px. Negative 6 equals 4p. Then negative 3 over 2 would equal p. And that's how we derive our graph for that. So y squared equals 4px, p0, x equals negative p. Horizontal is our y equals 0, would be our axis. Focus would be negative 3 over 2, 0. Directrix would be negative p, or x equals 3 over 2. And then axis of symmetry would be horizontal, y equals 0. That is part 1. Go back and look at it again. Get part 2 and part 3 at this email here. Thank you very much.